Good. So welcome everybody. My name is Martina Ivanicova. I'm leading data intelligence tribe at code.kiwi.com. I'm passionate about data and people, and I'm also a traveler, which is not a coincidence because I work at Kiwi. Kiwi, I'm not sure you know, but Kiwi is a company which combines flights, worldwide flights with other measures of transport and builds unique itineraries. And first of all, I was a bit hesitant whether the story I would like to share with you fits the scope of this meetup. But after I listened the previous talk from others, I'm pretty confident that it fits. So let's jump to it. So I would like to tell you, from my experience, let's say 10 years ago, how the data engineering world looked like. And back then, I was working as a data engineer in a traditional data warehouse. The warehouse was, one of them was for the big telecom operator, another one for a government agency. So I was part of the team which was building and maintaining ETL pipelines, which were extracting and loading and transforming data to warehouse, built into so-called star schemas, so facts and dimension tables. And on top of that, we enabled other BI tools, for example, SAP BO, to work with OLAP cubes. So that was basically 10 years ago. The part on the left side was one big relational DB, probably Oracle. There was a team of data experts, data admins sitting in one room, maintaining that huge DB, knowing the data models and so on. And then there was a team of backenders, then a team of front-end developers who were doing client-side user interface. I'm a bit simplifying, but this was the case. Back then, there was not really that the data quality or data discoverability, data reliability was not an issue. We didn't hear it as often as we hear it today. And I believe it was maybe for two reasons. The people back then, they were not so data savvy. So the typical data consumers were the business data consumers were people who were receiving their weekly or monthly Excel reports via email, or there were some BI tools, but people were not so using them in a self-service fashion. And also the system itself was pretty homogeneous. As I said, there was one big database, maybe some additional data sources, but that was basically it. And what happened in the last couple of years is that the world has changed. And nowadays we build applications differently. Nowadays, applications are built as microservices, so the self-contained services which are built around business capabilities. And these self-contained services have their persistence layer, have their front end, have their back end. They are typically deployable via CI/CD pipeline individually and so on. So this is what we do basically today. What is also important to say that this bounded domain around this bounded business context, they have defined interfaces, how to communicate to each other. So there is typically API, either REST API, GraphQL, you have Swagger, documentation, and so on. So there is contract present for how to communicate with these services. And what is important to say, you don't have anymore this like people separated by their specialty. You have like feature teams, full stack teams who can deliver from end to end, so from front end to deployment, and also they can maintain the system and so on. So this is today, and you see just like maybe 5 buckets here. What is in reality, or maybe if I can bring it to context of Kiwi, there are tens and tens of services like these. So this is one thing, but this is not all. We are also interested in other data, in data from external sources. If I can bring it to the context of Kiwi, we collect the app reviews for mobile apps. We collect social media sentiment. We purchase market data to understand what is our competitiveness. Then we are using stream data. We have Kafka cluster, which enables us analytics on top of the web and mobile events to better understand what our users do. Then there are some software as a service tools which we want to integrate. So this is the ecosystem as of today, pretty much heterogeneous and of a different stack. But what we still do typically today is that we still have one central data lake or data warehouse, and we have typically one central team of data engineers and analytic engineers, which are pulling the data from different sources and trying to clean them up and maintain these pipelines. So if, again, I can give you examples, several hundreds of pipelines, one central data platform team, and no contract between data producers and data consumers, because what you still do in this case is that you have some ETL pipeline, which goes to the database and pulls the daily or monthly or even hourly or 5 minutes increment of data and sync them to some center storage. Same applies with the streaming data and so on. So no contract between data producers and consumers. And I think this is a crucial point. And I try to illustrate it with the next slide. So imagine you are invited to the dinner to your friend, and what you expect is that you will be served nice food, safe to eat, safe to consume. But instead of this, you will go and to your friend's fridge and pick food from the fridge. So obviously, this brings some challenges. So you are asking, is it fresh? Is it consumable? And what is this item here? So this is exactly the same feeling what a data engineer or analytics engineer has. And this is actually really pain. And how this pain demonstrates is I put together a slide of several quotes I collected, either from interviews or from an internal survey about like what people see as the biggest data challenge in their daily life. And I asked this to product analysts, to analytics engineers, and so on. So let me just quickly walk you through this. So undocumented tables, data quality issues, missing a good data explanation, poor data quality, and the last one, my favorite, I don't understand what data I am looking on, because this one is actually nailing it down. So these quotes are from, as I said, from a survey and interviews, like 1 year old. I would be maybe happy if you can share your challenges, your data challenges you faced before. You can feel free to share it in the Zoom chat. I might add them to this slide if I do the presentation again somewhere, so feel free to add your data challenges. But long story short, this was it. And we, as a data engineers, are techie guys, so we were like thinking about tech solution to this problem. So people were complaining about the consistency. So we developed an automated consistency checks tool. Then there were like issues with schema changes on source systems or source DBs, which caused breaking changes downstream. So we developed the internal tool, which is integrated in a GitLab CI/CD pipeline as one stage, which detects the schema changes in a merge request. So if merge request contains, some breaking changes or any changes because of the Alembic migrations. Alembic is a Python Python schema changes management tool. So either Alembic migrations or SQL DDLs changing the schema. Then this tool queried our data lineage, storage, and understood what are the downstream consumers and alerted them on Slack. Then we thought that people are unable to find tables, unable to understand models. So let's focus on the data catalog. So we scrape the metadata from all the data sources, also from all the data warehouse tables and data sets, and put them in a data catalog. And last but not least, and I am happy I put this here because this goes in the direction as the previous talk. We had a similar idea, so we developed a tooling for custom data quality checks. So the internal tool, what you actually do is you create a simple YAML config file, you put it to any Git repository, which we have integrated. And then we have a service which takes the YAML config file, evaluates the query which is in it, again, and runs it against a dedicated database, either Postgres database or a BigQuery. So by this tool, with the use of this tool, you are able to write any business check which you can translate to SQL. So this one is quite pretty used in Kiwi nowadays. So these action points relieve the pain, but they were still not the silver bullet, because still this friction between data producers, data consumers, between domains and one central team, which has deep expertise, specialty in data engineering, but very little understanding of each domain's problem still persisted. So we were looking for the next steps, and we were inspired by 2 papers on data mesh, published by Jean-Marc Dengani, and we tried to understand the concepts and actually bring them to life. And what does it actually mean is that we were trying to change the mindset, bringing this notion of data products to these bounded domains. This just doesn't go from the day to day because you don't have the skill set there, you don't have the understanding. So it's not only technical change, it's more social or organizational wide change. But so the next step was to really break those silos and get the buy-in from the engineering teams, help them either to upskill or bring some of the people from the central teams to these domain teams to work together side by side. And what we achieved is that now we are maybe in the like 1/3 or 1/4 of this like whole process, but what we already achieved is that we have these the software engineers who are owning like given service, who are now publishing their data in an agreed format for anybody in a company to consume for any purposes, either analytical purposes, ML purposes, to derive data insight, to do the exploration, and so on. So what is still, so the concept is that these data products are decentralized, but what is centralized is a platform, tools, data standards, governance, catalog, all these things I listed on the previous slide. And this is still in the hand of the central data platform team. So probably you are asking for some more concrete, like what does it mean in real life? So I just want to maybe share you a couple of examples so you can frame it, to better frame it. So we went from the setup, as I explained at the very beginning, to the setup where we have these domains with bounded domains who are producing the data. Then we have other data consumers who are building their own data products based on that data, combining with the other data products from different domains and so on. And if I can give you one example for our 2 or 3 examples, we have, for example, the partner portal for B2B partners. And this is owned by one team, this one feature team. And they started to publish the information, like the data set, which contains the commission configuration. So with the configuration, how much should we pay to our partners? And this is like really their data set, which is guaranteed by them in a given quality, well described with a semantic meaning in the data catalog. This is then consumed by price and loss by the revenue management people who are building another analytical product on top of it, which is because this is one of the inputs when calculating, for example, net revenue. But at the same time, this existing team also builds an analytical product which serves other domains. And this is, for example, partners payout calculation. So they are calculating how much should we pay every month to each partner. They are sharing this data sets. They are like source of truth of the data. They are sharing it with finance. They are sharing it with the pricing team and anybody who wants to consume this data. Another example is we have a team who is like, if you go to the kiwi.com and search for the flight, so what basically happens that you shoot out the request and get back the response. So all these like requests and responses is something which goes to our, call it search pipeline, are processed. They are like stored in a GCS bucket, then the portion of that, like some subset of these data then used to train the ML model, which then does the prediction of ancillary attachment rate. Then you also need to take this data, transform them, load them to BigQuery table to enable content analytics on top of it, or pricing analytics. So all this is now owned by the inventory team, which is organized around this bounded context. Yeah, so I hope that I managed to give you this idea, to explain it, like how we got it, what it actually means, how we try to implement, and yeah, what pain points we wanted to address. But probably this was just talk. It might be that you are interested in like more details, like what stack we actually use. So yeah, so last slide with explaining our stack. We use Airflow as a workflow orchestrator, like platform for orchestrating workflows. As you heard, if you heard the previous talk that was mentioned there as well, like alternative to dbt. We like trained all these teams, like 20, 30 teams to use Airflow to write their own DAGs, which is dynamic acyclic graphs. And we build a set of platform plugins, which makes the development of these DAGs easier. Then these teams are publishing their data, the raw data to GCS buckets, and then they are doing some like transformation and loading them to BigQuery. We benefit from as this is running, all the infrastructure is running in a Google Cloud, we are benefiting from the managed service of Google Data Catalog. So Google Data Catalog has an advantage of all the BigQuery tables being like automatically loaded and visible in the Google Data Catalog, and same applies with the PubSub. PubSub streaming. So you can easily search for them, and they are by default there. With the source tables, with the Cloud SQL tables, as I mentioned 2 slides ago, we implemented our own scraper, and we are loading the data to Google Data Catalog there, sort of like automatically. So then, besides that, the BI tools we are using then for really like end users who want to export the data in self-service fashion is Looker. So we built so-called LookML models on the top of the modeled data. So data already transformed in some data access models. Then we use Slack because our data governance tooling, the one I mentioned before, that we are, allowing for this custom data quality checks. So so you can specify this data quality check, which is executed regularly and then or on demand. And then if there is a failure or data quality issue, you can configure to get notification in your Slack thread. So we use Slack quite heavily, and also we will use Slack for notification about undetected anomalies and so on. And the Datadog for some real-time analytics or near real-time analytics. For example, we monitor the net revenue on a 5-minute with a 5-minute frequency. So these are data which goes to Datadog. This is it, and thank you for your attention. If you have any questions, I'm here to answer them.